notice here is that when I enter this command, interface fast Ethernet 01, it immediately changes to config interface mode, right? So the change happens immediately. That is the case for any and every command that you enter in a switch or a router. So lesson number 1 is think twice before you hit enter. Because whatever it is you've got on the command line, it's going to be implemented immediately. All right, so always be sure of what you're pressing enter on, okay? Because it goes into effect immediately. Something I wanted to point out here, they have these things called syntax checkers. I'm going to skip them because you guys don't want to sit here and watch me type out commands, right? But for you, when you go back to do your reading, when you're going through the chapters, this is where you learn command line interface, by doing, right? By typing. It sticks it in your head. So don't skip the syntax checkers. That's where you're practicing your command line interface. All right? So we talked about the enable command. The enable gets us from user exec mode into privilege exec mode. And then if I type configure terminal, now I'm in configuration mode. If I'm in configuration mode, then I'm ready to start changing things. This is what a command looks like. This is the syntax for a command. It is a command, and then it's always followed by a space, and then you have some number of keywords and or arguments associated with it, right? And so this is just kind of a very simplistic view of the syntax for any command line interface command. All right, here's 2: show IP protocols and ping with an address. All right, keywords, arguments. All right, here's the command. Here's the argument that follows. Here's the command. Here's the set of keywords that follow. When you're going through this course and following courses, this is the syntax they use when describing a command. If you see something in italics, it is an argument, okay? The boldface is the actual command and keyword, and then in square brackets is something that's optional. In braces, it's required, and then you can mix them, okay? So if let's use this one. Never mind the actual command. We're just using this as an example. But take a look at this. It says switch port security, aging, and then notice we have the curly braces. So we know that one of the things within the curly braces is required. All right, so it's either static or time with an associated time argument, or type, so it's switch port aging type, and the type you have to choose either absolute or inactivity. So those are the quote-unquote permutations for this command, right? It can be switch port security aging static, or aging time with a particular time, or aging of type absolute or inactivity. That's how you read that command structure. questions about that before I move? I just wanna make sure that that sits well with everybody, okay? All right. Lots of different help, and the cool thing is, it's context sensitive. Basically, the answer is question mark. You can use a question mark anywhere, and it'll give you help for that particular spot that you are in that particular command. You can use a question mark right in the middle of a command and hit enter, and it'll tell you what your options are next. So it's very, very helpful. Okay? You can be literally mid-string in the middle of a command and use the question mark to figure out what's next. There are a set of commands or hotkeys, keystrokes, helpers, if you will, that you can use when you're in a command line interface. But there's something that I want to point out in particular, okay? So don't forget this, because we are all very used to using the delete key. Do not use the delete key. It doesn't work in the command line interface.
Because if we
Don't ask me why. It will look like it works, but it doesn't. Okay? You can use backspace, but do not try to use the delete key. I never understood why, but it doesn't. Okay? I think it has to do with the original terminal emulation way back in the 80s, where it didn't support rewriting of a line, yada yada, VT100 type stuff. And so they never implemented delete key, okay? You can only use backspace. One thing that's real handy though is, they didn't talk about it here. They probably will a little bit later. But if you use the up arrow and the down arrow, you have a history of previous commands. So like if you're in the middle of a troubleshooting session and you ping one device and then you ping another device and you want to go back and ping that other device again, you can up arrow and it will show you the last command. And if you up arrow again, it'll show you the one before that. If you up arrow again, the one before that. So it's kind of nice. The up arrow, the down arrow will cycle through previous commands that you already implemented. Very handy when you're doing stuff multiple times, yes.
Is it ever possible to see commands from a different session?
Say that again?
Is it ever possible to see commands from a different session?
You can have multiple sessions open on a device. Is that what you're asking?
Well, like, let's say I was doing some things and then the session got terminated for whatever reason, and then I probably forgot a command that I used before.
Oh, it won't carry over. It won't carry over. It is specific to your session. So the question for the online folks that may not have heard that, if you're connected remotely to a device, and this has to do with remote connection specifically, because console is console. Until you're logged out, actually, I think it even goes on. It's interesting. I might have to test that. On a console port connection, it may carry over from session to session. If it doesn't time out, if you don't log out of the console session, but with a remote connection, what we call telnet or SSH, those remote sessions are specific to that session. If you get disconnected from that session, your history is gone. Okay? That answer your question?
Yes, sir.
All right. So, remember what we saw earlier? Default name, host name for a switch is switch. Default host name for a router is router. Real original. So one of the first things that we want to do is name a device. When we pull it out of the box, brand new, plug it into the network, we're going to configure the device, basic configuration. That's what we're learning here, right? The first thing we're going to do is give it a name. The command is hostname. We have some rules. It's got to start with a letter, can't have any spaces in it, right? The only special character that we're allowed to use is a dash, right? That's it. No underscore, just a dash. That's the only special character we can use. We can use letters and digits. And if you're using a 64 character host name, shame on you, because that's a seriously long host name. I don't know about that. So here's some examples. Right? We'll get you thinking here for a second. Clearly we're in a building, right? Switch, floor 1, floor 2, floor 3. It's a 3-story building, presumably. Is this a good naming architecture? Is this what we call it, usually what we'll call it is a schema, right? Or a scheme. Is this a standard naming scheme that we like? What would, for instance, here's something to think about. I have switch floor 1, and it's clearly one switch, and let's say it's a 24-port switch, and now I need the 25th user, so I have to add a switch. What is the second switch's name going to be? Anybody? We don't know, right? It's not obvious, is it? Because we don't have, this naming scheme that we see here, we've identified the floors, but once we go beyond one switch per floor, we don't know what the heck we're gonna call it, right? So we could call it, what if we added switch 01 dash floor 1? Now we can support like 99 switches on floor 1, right? That's a little bit better. So just a point of note, when you're creating a naming scheme, a standardized naming scheme for your network elements is a good thing, but you want to make sure that you capture all the possible nuances of your network, right? When you're creating that scheme. The command itself is easy. There it is, right? Let me scroll up, push it up a little bit higher for those in the back. Config T. Oh, you'll hear me say that, by the way. Let me point that out. It's something that I skipped already. Earlier in your reading, one of the things that it's going to tell you is the Cisco command line interface is smart enough to know that if you enter the first set of characters for a command, and enough of those characters so that it is unique and the only command that is available that matches that first set of characters, that's enough. So you can actually enter the command configure terminal by simply typing config space T and hitting enter. Because there are no other Cisco commands at the global configuration mode, which is where we would be right here, right, with the pound sign. We're in privileged exec mode, and at this point, there are no other commands that start with the letters CONFIG other than configure. So I can type config and then press the space bar. And for the configure command, there is only one parameter that starts with a T, and it's configure terminal. So I can just say config T, which is what you'll hear me say all the time. Config T is the same as configure terminal. It's shorthand. These are things that you'll learn real quick because they save you time, right? You can also use the tab key. So if I type in the word config and then press tab, it'll fill out the rest of the word, configure. And if you're not sure, if you entered enough, like if I typed in CONF and press tab, it'll tell me all the commands that match those first 4 letters. So if you can't remember whether a command had a dash in it or not, for instance, you can start typing a command and then hit the tab key, and it'll tell you the commands that match. Okay, very useful feature. So anyway, we go into config T mode, we go into configuration mode, and we just simply type hostname space, and then whatever the heck we want to call it. In this case, it's SW-floor1. And look what happens immediately. Our prompt changes, right? Right away, immediately. You press enter, it's done, right? You screw up, you type the wrong IP address, it's done. You can lock yourself out of a device. So be careful, when you hit enter, it goes into effect immediately. And that's exactly what it did. We just renamed the device, right? So now he has a host name. What other kind of stuff that well, how about configuring your password? If we want to configure a password, we go into config mode, config T, we're gonna put a password on the console. There's only one password. I'm sorry. There's only one console port on a device, all right? One thing that you will learn, it's very odd, I don't know why Cisco did this, but port numbering starts with 0, not 1. So if there's only one port of a particular type, like for instance a console port, it's console 0. Console number 0 is what this is saying, okay? The oddity is switches. For some reason, for switch ports, they decided to do it a little different. Switch ports start with 1. I don't know why they had to make an exception, but for switch ports, they start with 1 as opposed to 0. Routers and everything else, the ports start with 0, okay? So here we are, the one and only console port that we have, console 0, right? And indeed, I can shorten this command, line space con space 0. That's enough, boom, hit enter. Now I can type a password. Password Cisco, real tough one, right? Password space Cisco. Now when I connect to the console port, I have to enter the password Cisco in order to get into privileged exec, right? Or actually, sorry, to get into user exec mode. That's just to get connected to the device, right? The command login basically says allow login on the console port, okay? That's all it's saying. That's what that command is for. And then I type in, boom. Now, here's the thing. We've named the device, okay, with the hostname command, and we've applied a password. Guess what happens if I lose power right now? Bye-bye. All that configuration is gone. Because I have not saved it. You have to intentionally save the configurations that you have applied on a device. And this is for good reason, okay? Because it may be, like I said, you hit enter on a command, it goes into effect immediately and you lock yourself out of a box. Well, your last resort is to bump the box, reboot it. Call somebody up who's over in Alpharetta campus and say, hey, you know, that switch, the third one down in the rack, can you pull the power cord for me and plug it back in? Because I locked myself out of it. And it will forget that command that you entered that had the wrong IP address, right? So you save the configuration changes that you've made intentionally when you're comfortable that you've done so correctly. All right? Yes?
When you start regressing back to the previous lines you were at, is that you saving the changes you made?
Yes. When you're, I'm sorry, wait, ask that again?
So when you start like regressing, like how it goes from like sales 401 to config, if you go back from config to sales 401, if you made a change there, would that have been saved that way?
So it's saved, it's live, your changes are live in memory, okay? It's what we call the running configuration, but it's saved in RAM. Lights out, RAM goes blank.
Right.
Okay, so does that answer your question? If you do the history thing, it's fine. You can pull up prior commands and you can reuse. In fact, let's say for instance right here, I type linecon 0, hit enter, right? I go password, or pass is enough, pass, space, Cisco, and I spell Cisco wrong, and I hit enter. Well, no harm, no foul. I can re-execute that command. I can do the up arrow key, and it'll bring up pass, space, Cisco in the way that I typed it in wrong, and I can backspace and retype it correctly and hit enter, and I can change the password again. Right, so I can overwrite configuration changes that I've made in memory over and over and over again. We do it all the time, right? And then when you're comfortable with the changes that you've made, you can save them, right? That's one of the things that we'll learn to do with Link. Does that answer your question?
Yeah, okay.
Okay. There is a secondary password that is what we call the privileged exec password. Remember, we had the greater than sign is user exec. That's what we get when we first log in the device. We might have a password on the console like we were just saying, but that just gets us into the device and we get a greater than sign. There's not much we can do. So we can do some show commands, look around the device and see what's going on, but we can't actually change anything. In order to change something, we've got to use the enable command. That gets us into privileged exec mode. We can put a password on the enable command. That's what this enable space secret does. And in this case, the password that we're assigning is a real tough one called class. Okay? So enable space secret, and then the password that we're assigning for the enable command is class. That's how you read that command. Okay? So now, when I log into the device and I type the enable command, it'll prompt me for a password. And the password that I've got to enter is class. Okay? So that's what that command does. Another concept. We talked about console ports. There's only one, right? It's console 0. But there's these other things that we connect to when we're doing the over the network connectivity, the remote connections via telnet or SSH. If I'm doing a telnet or SSH session, I am connecting to something that is called a virtual terminal port, VTY port. of which there are 16. Okay? Now, for who knows what reason, again, don't ask me, don't know why Cisco did it this way. You can specify a range like this, line VTY space 0 space 15. That means all of them, 0 through 15. Configure them all just like this, yes.
How does that work when you configure the password?
That's what we're about to do. We're gonna configure via terminal the VTY ports 0 through 15. That's the command that we're watching here, that we're looking at here. And we're gonna assign a password, Cisco. When you actually do a show running config after the fact, it actually breaks it up into 2 groups. And I honestly, to this day, I have no idea what the deal is with that. It's puzzling to me, but you'll see it. You'll see it soon when you start playing in packet tracing. And then, of course, we turn on login. Did you have a question?
No.
No? Okay. So we've just done for the VTY ports the same thing. We've assigned a password, a Cisco password, to those users that are trying to do either Telnet or SSH. So we've named a box, we've configured some passwords, but you guys that are in the cybersecurity program, one of the things that you will run across as far as potential threats, if you will, is shoulder surfing, right? This is the notion that people can be walking around behind you or walking past your desk, gathering information. And what in this case are they gathering? Passwords. So you might be configuring a device like we just did, and if on my screen I can see, password Cisco. Oh, look, that router that he's in right there, it's got a password Cisco. I'll jot that down, right? To prevent shoulder surfing, we can do service password encryption. And what it does is it takes those passwords that we typed in clear text, and it scrambles them. So if anybody's walking by you, when you have a listing, a show running config up, what was previously a password in the clear is now scrambled. See the passwords now? They're scrambled. There's the console port password and the VTY. Notice, do you see it? See how it split them into 0 through 4 and 5 through 15? I have no idea why it does that. It's the weirdest thing. They're all the same. In fact, it makes no sense for you to configure 0 through 3 one way and the rest of them a different way, because you have no control as to which of these virtual terminal ports you're connecting to over the network when you're reaching out to touch a box, right, with your terminal server. So you have to configure them all the same, because it doesn't make sense to do it any other way. But why they break them up into this 0 through 4 and 5 through 15 is beyond me. I have no idea, but they do. But the point is that we have now, using this service password encryption command, we made it so people can't view those passwords that we typed in clear text, okay? Here's another example of why you need to do those syntax checkers, right? Notice there's a dash in this command. Password, this is one that if you don't use the cheat, which is the tab key, or just service space, pass, enter, right? You'll forget that there is a dash in the middle of this command. Okay? The problem is, during a Cisco exam, you're not gonna have the option, right? So memorizing these commands is part of the class. Okay? I know it's ugly. Trust me, I don't have a very good memory. So things like that bother me. There's this other thing called banner. Banner MOTD. MOTD is message of the day. They just shortened it just to make the command a little easier to type. This is the one and only one command in the entire Cisco iOS system that is multi-line. It starts with banner space MOTD and then the space and then whatever you choose to be the delimiter character. You can choose whatever you want. You can choose a period, you can use an ampersand, an exclamation mark, a pound sign, whatever. It doesn't matter. The stipulation is that it can't exist in whatever message you're going to write as part of your banner, because the next instance of that delimiter character is the end of your message, right? So if I'm gonna have a message that is stay out of my computer or stay out of my network, exclamation mark, exclamation mark. I don't want to use an exclamation mark as my delimiter character, right? Because I'm using the exclamation mark in my command. But the cool thing is, notice they did it all in one line here, this command, but they didn't have to. I could actually type banner space MOTD space pound sign and then hit enter. And it's gonna say enter your message and then end with your delimiter. And I'm gonna say stay, enter, out, enter of my network, exclamation mark, exclamation mark, exclamation mark, and then another pound sign. And when I finish with that final pound sign and hit enter, that's my entire message. So I can literally have a multi-line message of the day, and this is the only Cisco command that supports a multi-line command, all right? It's called message of the day. And when you log into the console port, or you log into VTY via Telnet or SSH, you're gonna get this message of the day that says, stay out of my network, right? And then it's gonna prompt you to log in. That's what the banner is for, right? To warn people to stay the heck out of your devices.
How do you enter the switch in 2.4.7?
I'm sorry?
How do you enter the switch in 2.4.7? Syntax checker. What do you enter in there?
Exactly what it asks you to. So notice what it's saying. Secure management access to the switch. So the first thing is assign a device name, right? Notice that 2.4.1 is device names. You see that?
Yes.
See right here, device names. So if you go to that section, it will tell you what the command is for entering a device name. So in this case, I would go here and I would say host name space SW1 enter, and it's exact and full command. Let's see why did they didn't tell us what host name they wanted me to use. Oh, I need to go in configuration mode. So configure terminal. Enter. Oh, notice what it says. It says name the switch SW-floor1. So, okay, so I'm gonna do that. Host name space SW-floor-1. Enter. Okay? It'll walk you through step by step. That's the purpose of the syntax checkers. This is for you to practice.
Yes, sir.
Okay?
Thank you, sir.
Sure. So I told you, config files. I told you, power off, whatever's in memory, bye-bye. All right, if you haven't saved your config, you're done. Gotta start back from scratch. 2 files, startup config, running config. Okay? Running config is what exists in RAM. The startup config, we actually store that in NVRAM, non-volatile RAM. So NVRAM sticks around after the power's out. That's a good thing. When the device boots, it goes through this and that, the other thing, blah, 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 boot, post testing, checking firmware, does a bootloader, reaches out into Flash after initializing it and grabs the config. And the config is whatever is called startup-config. That's the config file. All right? So when you're saving your configuration, your running configuration, you're saving it to the startup config. And we actually refer to it in those terms. The command is easy. It's copy. Because they're files, we just name the files. So if I'm going to boo. It's not gonna show me right now. I wanted just a I just wanted a slide for it because the video, the audio isn't coming out on the speakers here. The command is copy, run, space, start. It's that simple. Copy running configuration to startup configuration. That's it. You're done. You've saved it.
And, sir,
Yes,
how do we do the lab 1?
we're gonna get there. We're gonna get there. So copy, run, start, or we can delete the startup config. If we go to the Flash file system, we can actually see what's in Flash. We can use the delete command, DEL, delete space, startup-config to delete the startup file. We can also use an older version of the command called write erase to erase the startup config. We can do that to effectively reinitialize the thing to factory defaults, right? If we want to wipe out whatever it is somebody did on a particular box and start fresh, that's one way to do it. Blow away the startup config, bounce the box, it's got a fresh config. Nothing's configured on it, you start from scratch. these config files are just simply text files. Everything is simply text. It's a text configuration. It's a list of commands that is human readable. So to capture it, it's real easy. You can just use your terminal emulator, whatever it is you're using to connect to the switch or router, turn on logging, and display the configuration that's running by using the show run command. It'll spit out everything that's configured on the device. You capture it as a text file using your terminal emulator, and you save it as a file. That's literally how you can save the configuration for a device. It's just a text file. There's nothing special about it. Okay? That's what this section right here takes you through, capturing as a text file. But what they're using is PuTTY, and they basically just tell you, oh, turn on logging, and then save it to a file. All session output, assign a name, and do a show run. Notice I shortened it. Show run is the same as show running dash config. Okay? So if you hear me say show run, it's basically look at the configuration on your switch or router. Oh. Ports and addresses. So, do we have ports? Yes. Do routers have ports? Yes. That's the whole point, right? Do switches have ports? Yes. Do they have addresses? Maybe. Right? The idea of a router is to route between networks, which means each of the ports that are active on the router should have an IP address associated with them. Switches, on the other hand, not so much. Switches operate at what we call layer 2, something that you're going to learn about very shortly, and therefore do not have addresses on their interfaces. This is an example of configuring an IP address, specifically an IPv4 address on a PC, on a Windows box. Okay? So, you will hear this. This is the first time you are going to hear this, and you will hear this many, many times from me. Okay? People will ask, well, what do I need to focus on for the exam? If I say things multiple times, chances are there's a reason. Okay? And this is the first of those times. There are 3 things that you need to know, or 3 things a device needs to operate on a network. And they're depicted right here. You need an IP address. That's easy, right? That is your unique number on the network. You need to know how big the network is that you're connected to, and that is the subnet mask. That's the second thing. And the third thing is you need to know your default gateway. Your default gateway is your route, your gateway to the rest of the world. Okay, technically speaking, you can operate on your own network that you're connected to without a default gateway. That's true. But in general, the 3 things we need to operate on a network: IP address, subnet mask, default gateway. Okay? Commit those to memory. Pretty soon you won't need to even think about it. You'll know this already. Okay? And it doesn't matter if it's IPv4, which is what we're looking at right now, the dotted decimal notation, versus IPv6. Doesn't matter. Same thing. IP address, subnet mask. In IPv6 we call it prefix length. but it's the same thing. How big is the network that I'm connected to? And then default gateway, which is the address of another device that is your router on your network that gets you to the rest of the world. Okay? So those are the three things that we need to operate on a network. Here's an example on IPv6. Okay. How many people are familiar with IPv4 addressing already? Okay. So there are, and that's understandable. There's a lot of people that are not familiar with IP addressing of any type at all. And that's why you're here, right? Our goal is to give you that very broad base of knowledge that you need to understand what's going on in a network, and understanding what protocols are in use in the network. IPv4, IPv6, both can be in use simultaneously. I'll guarantee you, your phones right now have multiple IP addresses, IPv4 and IPv6, guaranteed. Okay? You have an IP address for the connectivity that's sitting on the ceiling, that Wi-Fi connection, if you're connected to the campus Wi-Fi. You have a separate IP address for the cellular data connection you have to your cell phone provider. Because trust me, they're doing everything over IP as well. And they might be doing both IPv4 and IPv6. They may be doing everything over IPv6 only. Just depends on how the network is architected, okay? If we're on a port and we want to configure an IP address, well, we just saw how we do it on Windows, but what if we want to do it? One thing that they want to talk about here. So there is, from time to time, you know, many of you might have a laptop that you bring to school and you connect to Wi-Fi. Well, your phones too, same thing. When you walk in here and you power up your laptop, or you come on campus and you have your smartphone enabled for Wi-Fi, your smartphone and your laptop have no idea what kind of network is in use in Gwinnett Tech. Your device has to ask, right? It doesn't know anything about the Gwinnett Tech network. You haven't pre-configured it for Gwinnett Tech's network, right? You might have entered your own credentials, your username, your password, that kind of thing, but it doesn't know about the network itself. It actually asks. The way that we ask is called, for the most part, DHCP, Dynamic Host Control Protocol. This is one of the protocols that you're going to learn a lot about, but it basically provides us a mechanism to query that white box on the ceiling in this classroom for an IP address. In fact, for all three of those things that we need, right? The IP address, subnet mask, and default gateway. DHCP. So these machines that are in front of you, all these classroom PCs, they're not configured with static IP addresses. We do that so that we can easily make changes to the networks that the classrooms are using. And when the PCs boot up, they just automatically adjust because we haven't hard-coded them for any particular network. We use Dynamic Host Control Protocol to just-in-time configure them, right? Just in time. As they boot up, they request an IP address from the network, and they're up and running. You heard me say a little while ago that a switch does not have IP addresses on its interfaces. That's because it operates at layer 2, underneath the network layer. It's not like a router, it doesn't have an IP address on every active port. But if we want to reach out to a switch to configure it, we need to assign it an IP address, because that's the only way that we can communicate with it, right? We have to be able to connect to a particular IP address. So we put that IP address into a special type of interface called a switched virtual interface. And in this case, and don't get too wrapped up in it, we'll talk more about those interface types in the future. But in this case, they've just chosen VLAN 1, okay? VLAN, the term VLAN is Virtual Local Area Network, VLAN. It gives us a way to segment a switch into separate isolated blocks if we want to. By default, all the ports in any Cisco switch, when it comes out of the box, brand new, no configuration, all ports are in VLAN 1. So in this case, we're assigning a management IP address to this switch so we can reach out and remotely configure it. That's what this set of commands are doing right now. So we're going into config mode, config T, interface VLAN 1, we assign IP address. Notice the IP address command. This is IPv4, even though it doesn't say IPv4. It is an IPv4 command. IP space address space subnet mask. Okay, that's 2 of the things that we need. Remember, there's 3. So we've specified the IP address, we've specified the subnet mask, and then we need to tell it no shutdown. Why do we have to do that? Because by default, these particular types of interfaces are automatically shut down. We actually have to tell the switch to enable the interface, this switch virtual interface. We won't get into the reasons why at the moment. Just trust that that is a thing. We have to tell it no shut. Okay? You had a question?
This is part of lab 1, which we need to do?
This is not part of lab 1. We haven't gotten there yet.
Oh.
So, after we configure the IP address, we do a no shut. That turns on VLAN 1. The next thing is that default gateway, right? We needed 3 things: IP address, subnet mask, default gateway. Default gateway is the way that we get out of the network. We need to tell the switch what his local router interface is to get to anywhere else. And that, in this case, is 192.168.1.1. So that's the address of his default gateway. Now, that switch is configured for remote access in the most basic sense. Okay? In the most basic sense. We've at least got an IP address. We can, no, plug my laptop. So to verify connectivity on a device, we simply use the command ping command. Ping is a really simple command. It's just ping space, then an IP address. That allows us to no.
Oh. Didn't see that coming. How long is it going to take for it to come back up?
I don't know, but I just lost the folks that are online.
Ouch. How'd that happen?
That's really annoying.
That's disgraceful.
Okay. Why? I'm getting no light. So that happens again. Huh. Okay. Okay. This is what we're, instead of wasting your time, here's how I'm gonna handle the rest. So as you can see, we're done with the chapter, right? The last remaining module was testing configuration or testing connectivity, and testing connectivity is quite literally pinging a device, right? Ping space IP address, boom. I think for the lab submissions, what I'll do is I'm going to create a little video for you guys, and I'll just upload it. I'll save it in class recordings section, okay? It's really very simple. Once you have Packet Tracer installed, one of the things that happens when you install Packet Tracer is it creates an association for the file name that is .pka with the program that is Packet Tracer. So when you go to Blackboard and you open up the folder that is the lessons folder, and then in the lessons folder there's a lab. You open the lab and there's a couple of things. For one, there's a YouTube video. If it's a Packet Tracer lab, there's a YouTube video that actually walks you through step by step the entire Packet Tracer lab. I will warn you that there are times where the IP addresses that might be present in the YouTube video might not match what you're doing. Just need to make sure that you're, using your noggin here, right? You're using the parameters that you've been given for your lab, but watching the way that they're doing it in the YouTube video. There's a couple of things. I don't care what you name the file when you save it, but remember to save it, number one, right? And when you open a Packet Tracer file, the first thing it asks you is your user profile information. You must change it from guest, all right? The default is guest, that's the name, right? I don't care what you put in there, preferably your name. You don't have to put your whole name. You don't have to put your email address, because I think there's a field for email address. Don't care about any of that. You must change it from guest. The reason why is because, and yes, it's not that I don't trust you, but there have been occasions where students will share their labs, completed labs. That is not possible if you change the user profile name. So when you open it and you change it from guest to, for instance, Mike, it resets the lab. So, therefore, cannot use the default guest, do the lab, and then share it with your buddy next to you. because they need to change their name on the user profile, and when they do, it's gonna reset the lab, okay? That's why I need you to change the name in the user profile, okay? So please remember that. The second part is, please save it, right? When you access it in Blackboard, it's a download, right? You're downloading it. So where does it land? In your downloads folder, right? When you save it, you're saving it by very nature. It opened it in the downloads folder, so you're saving it back to the downloads folder unless you do a save as. My recommendation is to do a save as and save all your labs in a particular folder on your laptop somewhere, right? So you have your labs, especially if something goes wonky. Okay, so number one, change the user profile name. Number two, save the lab when you're done with it. Okay, and I will show you in the video how to check on your results. There's a very easy way to go through. It actually gives you a little checklist of all the stuff that has to be configured in your lab, and it literally gives you little check marks if you've done it correctly. If you haven't, it's got an X mark, so you know what to go back and fix. So there's literally no reason to not get 100% on every single stinking lab. Serious, all right? So if you just don't procrastinate, change the name, save the file, upload it in Blackboard, done, okay? Now when you're uploading it, I also would prefer that you add just a note saying 100% complete or 98% complete, or whatever your completion percentage is, all right? Please also include that. So if there's a discrepancy, I can say, oh, it says it's 100% complete, but what I received was only 80%. Maybe you didn't save it all the way. Maybe you finished it, but didn't save the 100% completion, right? So, completion percentage, name the file, whatever you want to name it, don't care, and change your username, all right? That's what you're uploading as your lab submission. And I will give that to you in a video, as a recording, in Blackboard, okay?
How do we get it done now?
What's that?
How do we get the lab done now?
You can wait for my video if you'd like, or you can do exactly what I just described, which is download the PKA file from the folder where the lab is, and open up Pattern Tracer and do the lab. But I will be creating a video so that you can follow along with your lab.
Yes, sir.
Okay?